For part A, we want to find that velocity at a certain height. So we can just go ahead and stick that velocity in, or sorry, I should say stick that height in, which is 10 meters. And the units are appropriate, 10-meter fall, and distance should be in meters. So that's good. And then we can go ahead and calculate this. So the square root of 2 times 9.8 times 10. Or the square root of 196 if you want to do this calculation in 2 steps. So the square root of 196 is 14 exactly. That's a perfect square. So 14, and the speed will be in meters per second. V is in meters per second, so 14 meters per second. In part B, we want to know what's the maximum distance the container can fall. So we can go about this two ways. One, we could either stick in the speed v, or we could rearrange this formula for d. Personally, I think it's just easier to stick in the known value and then solve it from there. So what is that speed v? If we want to find the maximum distance, what's the speed? Well, we have to go through and read the problem carefully, and we're told that the speed, the container should survive as long as it does not exceed 30 meters per second. So that's our maximum speed. So 30 is equal to the square root of 2 times 9.8 times d. And to solve this, we will square both sides, get rid of that square root. 30 squared is 900. So 900 times 2 times 9.8 times d. And then we'll divide by, well, we have to divide by 2 and 9.8. And we can do that all together. We can divide 2 times 9.8, which would leave us with d is equal to 900, and this is something I'll have to do in my calculator, times 2 times 9.8. If you want to do this in steps, you can just calculate what's 2 times 9.8, which is 19.6, and then divide 900 divided by 19.6. 900 divided by 19.6 is equal to 45.9, and this is maximum distance, which is in meters. So 45.9 meters.